Welcome back. This is example 3 from 1A 1.5, or better known as 1A 5. This is 1.5, 1A 5. So we're looking at this example here. So we want to consider the balance spinner from example 1 associated with the random variable x having a PDF of f of x equal to 1 on the closed or half and half closed interval from 0 to 1. We've already shown, it's easy to see that the mean is a half and the variance is 1/12. And now we want to see if our simulated iterations are a good fit for this model of f of x. Okay, so we're going to do that using some technology. So we're going to jump over to GeoGebra and get started with that simulation. And I should also point out that this is a similar example to what you would do on problem 4, but the difference here is that you're given the data in problem 4, and in our example, we're simulating the data. So that will be the one small difference that you'll want to take into account. However, the treatment of the data once you have it will be the same. All right, so let's jump over there and get our quantiles. To do that, we're gonna choose 1 through 19 because the quantile relationships there as well, right down here, is equal to, I'll go one more down, is equal to r divided by n plus 1. So if we choose n equal to 19, if we choose n equal to 19, then that becomes r over 20. And r goes from where I should say r is equal to 1 through n. Okay, and so that's where we're going to go here. So let's go ahead and calculate those. We're going to have equals a1 divided by a1 minus a half divided by 20. And then we can capture this and pull it down. That'll compute all of the quantiles that we need. Okay, and then the next part is to create our quantile plot. We're going to pull the theoretical data. And so the nice thing about GeoGebra is it has a function called random, which random pulls in values, numeric random values from the interval from 0 to 1 from the continuous or from the uniform distribution. So we can pull that down, and that's going to create then our 19 theoretical samples. Okay, so now that we have our quantile values and our theoretical values, we're going to go ahead and make a list of these so we can sort them and put them in order and then compute them. So down here, we're gonna, if you right click on the column P, you can come down here and create a list. So that'll create our list here. L2 is already in order, so we don't need to worry about sorting that, but our random sample or our theoretical values are not in order yet, so we need to go ahead and put those in order. So I'm going to create a list here, and now I want to sort L2, and that'll create a list L3 that will be ordered from least to greatest. So we have our list or quantiles here, and then our theoretical values. Let's see, P is from the Q, P is from L1, and Q is from L3. Okay, there it is. Okay, and now you'll notice that these values go from 0 to 1, which is what we would expect. And so I'm just gonna right click on these and zoom to fit. So you get a nice little relationship. You can see here it kind of does a little hiccup there. So let's get a linear fit. So fit line, and then we're going to do that through L4. So there's our line of best fit through that, and you can kind of see that the data does line up pretty well. There are some little variations here and there that correspond to a little bit of gaps there. So that's interesting. We have only 20 samples, so we would need more data to really confirm, but this does look promising that it could be the correct model. So, all right. So we want to check one more thing just to make sure we have a better understanding of whether or not this data is a good fit for the model for the values being pulled from a uniform distribution. And so in GeoGebra, let's go ahead and create a box and whisker plot. GeoGebra calls it a box plot. And so let's take this first one here. We're going to do Y offset scale and then the raw data. So we're going to have just make these parameters, and you'll see what that does in just a second. And then our raw data, we're looking at the data that we are trying to fit to see if it fits. So we're going to go with our list one that we created earlier. Okay. And then these values here just help you to kind of scale to get a better view of the box plot. And so I'm going to move this down here just so we can kind of overlay it with the data and see what it looks like there. And so you can see the C value is there. And if you look at open up this a little bit. If you look at the box plot here, the fact that it's almost completely symmetric in regards to this shows that it in fact is a really good candidate, that this data does fit really nicely with the uniform data as we would expect. And so the combination of the QQ plot here with the linear regression showing that the data is lining up pretty close to the line, and with the symmetric version of the whisker and box plot here, you get a really good interpretation that this data is pulling from and is a really good model of the uniform distribution. Okay. All right. Well, I hope that was helpful, and I will see you in the next video.